Welcome to determining the bounds for area between curves. So note, so far, we have looked at cases where we were told the starting and ending x values. But sometimes the curves simply intersect. So sometimes the curves intersect and enclose a region on their own. So for example, let's find the area of the region enclosed between f of x equals x squared and g of x equals 2x plus 3. So in terms of what we would be looking at here, if we draw the graph, we are looking at, we have our parabola for f of x. And then our g of x, we have a function which has positive slope and positive y-intercept. And we're essentially going to look at the region enclosed that's below the line and above our parabola that we are left with. And so what we need to do is we need to identify what are those points of intersection. So we need to find the points of intersection. So to do this, we are looking at where does f of x equal g of x? F of x was x squared. G of x was 2x plus 3. So we are looking to solve x squared equals 2x plus 3. That means x squared minus 2x minus 3 is equal to 0. And we have x minus 3 times x plus 1 equals 0. And so that tells us that x is either 3 or negative 1. So we now know where we should start our integration. At this point, we can go ahead and set up our integral. Again, essentially, we are looking for the area between f of x equals x squared and g of x equals 2x plus 3 on the interval -1 to 3. So again, if we look at our picture, note that the line is above the parabola on this particular section of the graph. So note g of x equaling 2x plus 3 is greater than or equal to f of x equaling x squared on this interval of interest from -1 to 3. So when we go to do our area, the area will be equal to the integral from -1 to 3 of g of x minus f of x dx. So we are looking at the integral from -1 to 3 of 2x plus 3 minus x squared dx. This becomes x squared plus 3x minus 1/3 x cubed, evaluated at -1 and 3. So we have 3 squared plus 3 times 3 minus 1/3 times 3 cubed. Then we subtract off -1 squared plus 3 times -1 minus 1/3 times -1 cubed. That top part, we have 9 plus 9 minus 9. So we are just looking at 9, and we are subtracting off. We have a 1 minus 3 is -2, and then plus a 1/3. We have -5/3. So we are looking at 27/3 plus 5/3, or 32/3 for our area. So this is how we can go about finding area between curves when we need to find our bounds. In our next video, we will look at the case where we have multiple regions enclosed, not just one.